Let's humble ourselves with a word of prayer. Almighty Father, we thank you for the new day that you have opened unto us. We thank you for the new blessings that you're raining unto us, Jehovah Jireh. We believe in you for better things are yet to come. And as we begin this lesson, please send your Holy Spirit to guide us, that we may master everything that we are going to learn. And it may help us excel in the final exams, Almighty Father. Bless our teacher, bless everyone who has been able to come here, and bless everyone that is supporting us to be able to attend these lessons. In Jesus' name we have prayed and believed. Amen.
Thank you so much for the word of prayer. Today we are going to look at another section, and we are going to concentrate on something in this section, and we are going to look at geometry and measures. But here I will also look at a bit of trigonometry when it is being applied in this section. So we shall look at the area of trigonometry. But in this section, there are three things that you need to know. One, these are the must know shapes for you. There are some shapes at least you must be able to know. And when we ask for a two-dimension figures, these are the figures whereby you must know how to obtain their areas. So for these figures that are 2D, the main thing they ask is about finding the areas, finding the surface area, finding the perimeter. So for any of these shapes, you must know how to find its area, how to find the perimeter. When it comes to three-dimension figures, these figures here, you must be able to find what we call the volume and what we call the lateral surface area. Sometimes they can call it the lateral surface area, or sometimes they can call it the curved surface area. Those are the common things they can ask when it comes to the three-dimension figure. Now, when it comes to the square, you need to know how do we get the area of the square. You know that area will be given by side times side. What about when it comes to its perimeter? You know that the perimeter of a square can be given by 4s. That is whereby s is the length of the side. Then for the rectangle, still you need to know that area is given by length times width. What about its perimeter? Its perimeter is given by 2 into L plus W. When it comes to a circle, area of a circle is given by pi r squared. What about the perimeter? Put for me the chart. How do you get the perimeter of a circle? When they ask you for the perimeter of the circle, what shall you have? So perimeter of the circle, remember perimeter means the distance around that figure, the total distance around a figure. So, thank you, Kathy. So when they ask for the circle, remember the circle is like this. So the total distance around the circle here is what you call the perimeter. So for that case, they're asking you indirectly the circumference. So it will be 2 pi r. That is when it comes to a circle. When it comes to a triangle, okay, or the pi d, okay. When it comes to a triangle, that one on that area is given by the half times the base times the height. However, when it comes to these triangles, you need to be very sure. Sometimes you need to apply the knowledge of trigonometry, because sometimes they can give you a triangle. Let me say they have given you this, or a figure of this nature, whereby they have given you an angle. Let me say they have given you, this is, let me call it angle A. So you need to remember your knowledge of trigonometry, that this side where the angle faces is what we call A. In case, let me say this is where I have A, this is B, and this is C. So the angle here is what we call C, the angle here is what we call B. Now in case it is in terms of trigonometry, then this side here we call it B, where this faces we call it the C. Now, in case it is in terms of trigonometry, the angles you are finding, then that means I expect you to remember that area will be given by AB, and then you write sine of C. In case you have not used that one where you have used B and C, then here use the other side of A. In case you have not used that one where you have, the next one will be, we have done A and C, then the angle here should be B. So at least you need to remember this knowledge when it comes to trigonometry. Now, these are the common things they can you or you can be asked when it comes to a two-dimensional figure. Then when it comes to a three-dimensional figure, we have said that here, the common thing you need to know is what we call the volume. Now, the volume, we know that for a cuboid is this figure, like those boxes you carry, where you put your books, those boxes where you put clothes, yeah, those suitcases, those are the cuboids. So you know that this one has the length, has the width, and has the what? The height. So volume means that you can carry water in that particular item you are holding. Those are three-dimensional figures. As long as it can carry water and you take it somewhere, then it means that it is a three-dimensional figure. It means that it has some height. So for that one, the volume is given by the length times the width times the what? Times the height. Now here they can as well ask you what is the total surface area. So the total surface area, do not forget that for it, you're going to come and know the area for this side. Let me say that is length times height. The length for this side, which is the WH, then you have got this side which is WH, this one down which is plus the WL. But everything here, you're going to multiply it by 2. Since you have this side, you have this side. You have this side, you have this side. You have up and you have down. That's when they ask you the total surface area. So it is always 2 into length height plus WH plus WL. That is when it comes to a cuboid. Then when it comes to a cube is like a square, but when it is a cuboid. So a cube for it has equal sides. All its sides are equal in length. That is when it comes to a cube. So that one, in case they ask for volume, it can be length times length times length, which you can summarize as L cubed. When it comes to the total surface area, you know that total surface area, like from here, we have said is LL. So for it, it's going to be LL plus WW plus maybe HH. But remember, all these ones are the same. So you have LL plus LL plus LL. So L times L, which gives you L squared plus L squared plus L squared. And this one will give you 2 into 3L squared, which will give you 6L squared. So that is when it comes to those things of a cube. So you need to know how to deal with such figures. Then when it comes to a cylinder, for it now, this one is very important, a cylinder, and when it comes to a cone. Now those two figures originate from something. I've not added a pyramid, but let me start with a pyramid. Now, when it comes to these pyramids, the pyramids comes from here. That's where the pyramid comes from. And when you look at this figure is like when you look at it very well, it looks like a cuboid. So if this is the length, this is the width, and this is the what? Height. For a pyramid to be able to obtain the pyramid we have here, we get it from this figure here, which looks like a cuboid, but this is a prism in nature. And when you look at it, you notice that the volume, to get the volume of this figure here, is given by length times width times the height. But just this one part here, you see here down, this is just one part of all the total parts. The total parts here, this is 1, 2, 3. So this part here down is 1 out of the 3. So this figure you are seeing here, it takes just 1 out of the 3 of everything. So that means that to get a pyramid, to get its volume is just 1/3 of the total volume of everything, which is the length times width times the what? The height. So whenever they ask you to get the volume of the pyramid, it's just 1/3 of the length times width times the height. And sometimes you can as well have it as 1/3. Length times width is what we call the base area. So which can be the base area, then times the height. That's when it comes to the pyramid. Now, when it comes to the cone, a cone originates from a cylinder. That's where the cone comes from. Now, when it comes to a cone, to a cylinder, you know that the volume of a cylinder is given by pi r squared h. That's how we get the volume of this cylinder here we have, whereby pi r squared is the circular thing we have, the circle. Then h is the height. But in a cylinder, to be able to get a cone occupies just a third or one out of the three parts of the whole cylinder. In other words, when I get a cone where there is water and I pour it inside the cylinder, I'll just get a third. So that means that to fill the cylinder, you need three cones to be able to fill it. So a cylinder is just one third of the total parts that make up the cylinder. So to be able to get the volume of a cone is going to be just a third of the total cylinder, which is pi r squared height. That is when it comes to a cylinder. Now, but still here, I want to bring it to your attention that sometimes they may ask for the lateral, for a cylinder, they can as well ask you to find the lateral area. Lateral area means that when you look at our cylinder here, when you look at our cylinder, this part that is curved, this part that is curved is what we call the lateral surface area. This curved part here is what we call the lateral surface area. And when it comes to the lateral surface area, we are looking at that side that is, this side that is curved, only here, this part I've shaded, without the downer part, in other words, this part here. Yes, this is the part that we are looking for. So for it, it doesn't have the like a bottom, but you just look at that round things. That's what we call the lateral surface area, or sometimes we call it the curved surface area. Now, in order for us to be able to get that one for the lateral surface area of the what? Of the cylinder, we know very well that this one here is like the diameter. Then in the middle here is where we have like the radius. This one here is what we call the height of our figure. So you know very well that when I rotate like this, this is like a circumference. So to get that lateral surface area is given by 2 pi r. 2 pi r is the circumference, then times the height. So whenever they ask you to find the lateral area, the curved area of a cylinder, this is how you find it, 2 pi r h. However, if they tell us to find the total surface area of a cylinder, you know up here it has a circle. That circle is given by pi r squared. Down here it has also a circle, which is given by pi r squared. So, and we have said this part that is curved is given by this. So to get the total surface area of the cylinder, you add your pi r squared plus pi r squared plus the 2 pi r h, which will give you the 2 pi r squared plus the 2 pi r h. So here, the common factor is going to be 2 pi r, and then when you factorize, you get that. So that's how we come up with that formula for the total surface area. But sometimes they can tell you the cylinder is unopened. So if it is just an open cylinder, that means up here, you'll now neglect one of the circles. And now your formula will become pi r squared plus 2 pi r h. That is when the cylinder is open at both ends. So I want to bring to your attention that the curved surface area, when I open the cylinder, it is that figure that looks like that. So, and for it, this curved surface is the one that gives us the 2 pi r, and this is the h. So we get it from that point there. So let me hope that summary is enough for you. Kindly let me know through the chat whether we have been able to pick. But maybe the last one is for a cone. A cone, the curved surface area is this. Now, if they tell you to find the curved surface area when it comes to a cone, for it is given by pi r L, whereby L is this slanting length here. That's what we call the L. So in case they tell you of a cone, this is how you get its curved surface. Take an example, you know they can give you a figure and they only shade up here. So if that one, if you notice that it is a curved surface area, then you get pi r times L, whereby L is the slant length. Let me hope we are on the same page. That one I was just reminding you about the important formulas and then for the important figures. Are we on the same page? Oh, how do you know the cylinder is closed or open? They will always state, they would you look at the figure and then they will tell you that let me give you an example. In case it is a cup, you know a cup is like a cylinder, but up for a cup, it is an open one. That is for a cup. When let me say I use a figure like which figure is closed? The like this cylinder where we put gas. Now that one is a closed one, both ends. So that's how you can distinguish the two. An open one, it's like a cup. Then a closed one is like that cylinder where we put the gas. Okay. Now the formula for the lateral surface area of a cylinder for a cone is given by this pi RL. Mm, mm. Then for lateral surface area of a cylinder, for it is given by 2 pi RH. Okay, now let's start. We are going to start with this is Jjeb, then we move on. Now, when you read through here, you can first read through. Now, when you look at a metallic tank, that are made. I've put for you an example here for those who don't know them to figure them out how those tanks look like. This is how those tanks look like. And when we look at those tanks in the chart, you told me, do they form an open cylinder? They form a closed one. Tell me, is it open or closed? That is now the first thing to help us. Does it form open or it is a closed? Uh, uh. Okay, some people are saying open, other people are saying closed. Uh-huh. Okay, I don't know that someone can raise up the hand and anyone who's telling us open and another not telling who's telling us closed, and you give us your reason why you are saying open and another who is saying closed. Okay. Yes, Daniela.
Good morning, sir.
Morning.
So may I go with the closed because I've never seen an open tank, because now if it is open for sure, when let's say it rains or something, the particles from the environment will just be entering the tank.
Wow, thank you. Uh-huh. Proscovia, do you have the same answer?
Mine is open
Uh-huh, okay. Give us your
because
reasoning. Mm.
those metallic tanks are always
Mm.
open. You just get a cover maybe, but are always open. Thank you.
Okay, okay. Yeah. So I'm going to okay, the last one, Brian.
Teacher, may I say it's
Mm.
closed because
Mm.
I'm seeing, first of all, an inlet pipe that's to take
Mm.
in and an outlet pipe down that's to take out water. But
Mm.
there's no being open. I think it's closed.
Okay. 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 Okay, thank you. Now, when you look at the two reasons, we shall go in with the first and then the third person. Those tanks, one of the reasons that they have given us is that when you leave that tank open, remember it rains. The use of these tanks is to collect water. Now, if you leave it open like this, it means that anything can come and fall inside. So at the end of the day, you'll have dirty water. So those tanks are always closed. Any tank I think you have seen, it is always closed. They just leave a small outlet here, like a small one here, just to be able to fix the pipe that brings in the water. But also up here, these days, they cover it with a net such that the particles do not fall inside. Otherwise, if you leave it open completely like this, just know sticks can fall in, the birds can come and swim from your water, monkeys can come, everything, everything. So that's why they close them completely. I don't know whether now we can agree that this tank that we are going to deal with is a closed one. Do all of us now agree? Proscovia agrees. I saw some people were saying I wanted to hear from to hear from Kathy, Virginia, and Olive, whether now we are on the same page. Okay, they agree now. Okay, now here they are indirectly asking you to obtain the surface area of across the tank. Now, I know how are we going to do it. They told us that the tank they want to make is 12 feet and a height of 2.5. If this is the tank that I'm going to assume, here it is 12 feet. And up here, it is a tank of 2.5 meters. Now, I want you always to check out one, when they mix these units, you must first work out with the same units. But when you continue to read through, they're saying that the tank is made up of metallic pieces of dimensions 8 feet by 4 feet. Like when they're making the tank, we don't have that iron sheet that can make the tank at once. No, they just get small pieces. They get a piece, mix it with another one, like that, until when the circular thing comes out. So when you look at those tanks, you notice that there are several pieces that they keep adding up to come up with the complete figure. Now that is the one they have given us, which is 8 by 4 feet, and they have told us that each of them is sold at 80,000. Now, to bring it to your attention still, what they have given you here is what we call the iron sheets. Those iron sheets that make up those metallic ones. And when they are selling them, it is sold in feet. So 8 feet like when you get your feet, your foot there, your leg, like your foot, like your shoe. Your shoe is 1 feet, your shoe. So you count, you put it there, you fix your shoe 8 times. So you'll find that this is like the height, which is around 8 feet, and then this one is the 4 feet. And now the question is, how many of these iron sheets shall we need when we are coming up with our tank? That means that the first thing we are going to find out, what area is being covered. But when you look at the dimensions here, they have told you that it is sold at 80,000, meaning that they have calculated in form of feet. Meaning that whatever we are going to deal with also, we are going to first convert them into feet. So we are going to convert these 2.5 meters into feet. But remember, the question here has given us a hint that within 1 meter, we have 3.3 feet. Can everyone first convert in 2.5 meters? How many feet do we have? Can we convert? And you put what you are getting in the chat. Okay, let me first get my calc as well. Okay, people are getting 8.25 feet. Very good. So now I'm going to take you to a new page here where I'm going to draw my simple tank. So this is our simple tank. And when it comes to this element, please go on and make those sketches. This is 12 feet. And now here you are going to allow me. And please do not forget to show how you have converted that 1 meter is equal to 33 feet. Then how many meters are you looking for? 2.5. So 2.5 will equal to how many? So which gives you 3.3 times the 2.5. And from the chart, people have said that one gives us 8.25 feet. So here I'm going to put 8.25 feet. Since we have agreed that this metallic tank that they want to make, we are going to find the surface area. So I'm going to say uh, surface area of the metallic water tank. Water tank. Even here they told you water. So now we say that to get the surface area, we say that you get the lateral surface area, or I can just put the formula here, 2 pi r plus h, whereby r is your radius and h is your height. So you're going to obtain the radius. So you can come here and say, now my radius will equal to 12 feet divided by 2, which will equal to 60 feet. So now whenever they don't give you pi, please make sure you stick to 22 out of 7. So here we shall come and say this is 2 times the 22 out of 7 times r, which is 6, into 6 plus the height, which is 8.25. Then you'll continue and say this is 2 times the 22 out of 7 times 6. First deal with what is inside the bracket. So you say 6 plus the 8.25, which gives you times 14.25. Can everyone compute and get the answer? Compute and get for us your answer you are getting for that part. I'm looking through the chat. Hunter is getting y divided by 2. We are converting Daniela to radius because they gave us the diameter. They gave us the diameter, but we need to use the radius, the formula. So people are getting 5, 3. And now for whenever you get these ones, 5, 3, 7.4285. I'm going to advise 7, in fact, 14 feet squared. Now, I will advise that in case what you are still dealing with is going to be utilized in the next parts of the question, or in the next parts, like if you have not yet come to a conclusion of your answer, then make sure that you write as many decimal places as you can. Before you reach the final one, you can write as many decimal places as you can. But at least you must write 4. At least 4, but not less than 4, such that your levels of accuracy are within. So here, the least number of decimal places I expect you to write should be 4. But remember, I told you avoid rounding off from the calculator. So when you look at Hunter's answer that he has given, he has just rounded off from the calculator. Yet the value that came after 5 was a 7, meaning that he could have rounded off up to 4286. So now this one can lose a mark for the accuracy level. Hunter. Okay, now this is what we are getting for the surface area of the metallic water tank. Okay. Yes, Kathy.
Teacher, good morning.
Good
Teacher,
morning.
may you repeat for me the formula? I'm not understanding it. The 2 pi r in two brackets r plus 8.
Okay, you stay on. Now that formula came from here. Are you seeing?
Yes.
It is like this, eh? Now down
Mm.
here, which figure is this?
It is a circle.
A circle. How would we get the area of a circle?
Pi r squared.
Pi r squared. Then also up here we have a circle. It's also given by pi r squared.
Squared.
Now this part here in the middle here, which I'm dotting, it is a
Mm.
curve. It is like a curve of this nature. Now
Okay.
this curve, when you look at it, it is forming something circular like this. And that one is what we call, it gives us what we call the 2 pi r here, 2 pi r. And then this one is what gives us the edge. So this part here is also its area is given by 2 pi r h. Now to get the total area of the cylinder, you add this, and that. Are we there?
Okay.
Eh,
Yes.
So when you add the pi r squared plus the pi r squared plus the 2 pi r h, pi r squared pi r squared, you get 2 pi r squared plus 2 pi r h. So for you, if this one is confusing you, you can deal with this. If you can, 2 pi here and 2 pi are common, so you can remove it. R is common, I can remove it. So the moment I remove, here we had R squared, it remained R. Plus here, we remain with H.
I've understood.
Okay,
Thank you, teacher.
okay. Now, after getting the surface area of the metallic water tank, we are going to find the iron sheet they used to make. What's the area of that iron sheet of 1? So that is what we are going to find out. So I'm going to come here and say area of the, they called it area of the metallic piece. Now, when you look at the area of the metallic piece, those who don't know, like it is a figure of this nature. That is how those pieces look like. And here it is 4 feet and this is 80 feet. So to get the area of this figure is, these are iron sheets that are rectangular in form. So to get its area, you're going to come and say that area will equal to length times width. And now this one will give us the 8 times the 4, which will give us the 32 feet squared. Are we still on the same page? Are we still on the same page? Okay, yeah. Then after getting those two, we are going to go on and find the number of metallic pieces that they need. So to get the number of metallic pieces they need, allow me to write in this area here, number of metallic pieces that are needed. So I'll come and say number of metallic pieces or number of pieces of the material. So that means we are going to get the total overall area, which is 537.42857114, divide by the area of one small part. So we divide that, divide. So when I divide from my calculator, I'm getting 16.794642886, something like that. Hope you are getting the same. These are the pieces that I'm getting. So, but I told that under this element of construct, we are allowed to estimate depending on reality. So, what could be your answer for this? People can put for us in the chat. Okay, Hunter say that. Megan, yes. Okay, very good. Yeah. So here we could approximate and say now these are 17 pieces. So then after, remember you have to respond. Then you will say that the number of pieces of the material required to make the tank are 17 pieces. So that's how you can make your conclusion. Yes, Kathy?
Sorry, teacher, I forgot to lower my hand.
Okay. Mugisa?
Yes, good morning, sir.
Good morning.
So my question is, if this 7 you cannot round off, then and you get one
If it
to
can't?
add, to be added to 16 to get 17. If it is like a 3, if
Mm.
it's like 16.3, can we also write 17 or we can write 16?
Oh, now you ask yourself, when I buy 16, will everything be covered?
No, they will, the smaller part will remain.
Aha, yes. So meaning that the work will be incomplete. So that one you round up.
Okay, thank you, sir.
Okay. Yes, Gavanian. The rest, please continue to do part B. Gavanian,
Morning, sir.
good morning.
Master, I wanted to ask you, is it a must that you have used 20 over 7? Because even that, even
To do
3.1
what?
local.
Is it a
Is
must
it a
to?
is it a must that you have to use 22 over 7?
Yes, because whenever it is not given to you, you use that. That is the standard thing.
Or
Jeremiah, Jeremiah,
Good morning, sir.
good morning.
I was asking whether that 16.7 can be just left like that, or it's a must that we have to round off.
Now it is a must here in this element of construct of geometry and measures.
Yes.
You round off to the reality, which one can be achieved in reality, because you cannot go to the shop and you tell them I need 0.3222 what. Yeah.
Okay, sir.
Yeah. So they sell for you a full one and then for you sort yourself out. I think people have got the money. Now for part B, how much money is used to buy the required pieces of the material? Remember, the materials we had were 17 and how much money do we need was 80,000. So we shall just say part B, the cost of the materials needed, of the material needed will be our 17 times the 80,000. So when you multiply, people are getting 136,000. And I think if you
And
have observed me, I always love writing the work, yeah, vertically. So here then you'll conclude that the amount required is 1.360,000. Then part C, here they use shillings. So also here you stick to shillings. Eh. Then the third part wanted us, should they use, now the second part, second paragraph. They want to paint outside part of the tank, excluding the bottom part with paint, which is sold in either jerry cans or cylindrical tins. A sealed jerry can, which costs 23,000, can paint this, and a sealed tin, which costs this, can paint this. Now, what are they asking you? Now, when you read through the question, they are asking us what happens when we exclude the downer part. In the chart, you tell me which type of cylinder do you think they want to paint? Eh, open, closed. Uh, aha. Very good. People have clicked. Now it is open. Indirected, now they're asking us, can we find the area of an open cylinder? Remember Proscovia? Open. Very good. Very good. Yes. So can we find now here they're asking us to find the area of the open cylinder first. So I'm going to come on part C and say the required area or like that. Then I will say the total surface area. So we say that is open. For open, we said we only have the one circle, then plus the 2 pi r h. Hope that is okay. So if you wanted to simplify this, there was no problem for you to factorize. I can factorize it out for you. Here pi and r are common. So here you remain with r, here you remain with 2h. That is for the open. In case you want it in summarized form, this is how you write it. So, yes, Mugisa?
Excuse me, sir.
Yes.
Here, if I get the area of the circle, for example, the base area of the cylinder, then after getting that area, I get that the total lateral area, then minus that area to get the area of the surface to be painted. Can I be right?
Yes, it is okay.
Okay.
Okay, so when I go with this, it will be 22 out of 7 times our r, which was 6, into 6 plus 2 times our height, that was 8.25. So here I'll continue and say this is 22 out of 7 times 6. Then you work out what is inside your bracket. So let everyone be working out. And then you put for me which answer you are getting in the chat. When you get, feel free to put for us which answer you're getting in the chat. Okay, I'm waiting for your calculations, which answer you are getting. Okay, I'm seeing an answer. Yes, Patricia.
Good morning, sir.
Good morning.
Okay, sir. As I was trying that number earlier on,
Mm.
I didn't use feet, like I converted to meters. Is it okay?
Now, where it wouldn't be okay would be on buying the iron sheets. Did you come up with the same answer or you just assumed?
What? Okay, what I got was 16 point. Is it 8 something? Then I rounded it to
No,
17.
like you can get the same number of iron sheets, which is okay. But now when it comes to the buying, this one of buying, it shows you that they bought in fits.
Feet.
Now, for you when you are making your calculations there, I don't know whether it came out but I know it can come out very well, but the reasoning can differ. Because now for you here, you have bought in meters. For you, if you convert them to centimeters, it means that for you, you have bought in terms of centimeters.
Okay.
In fact, in form of meters. So I would recommend that we work with feet.
All
And
right, sir.
also in reality, when you are buying iron sheets, you are buying those metallic. Many times they are sold in meters. If you have bought iron sheets, they sell them in like they're in feet. Yeah. Okay, so this is the area we are getting, which I can say these are feet squared. But now, still, I want to warn you here for this particular part. I know another person would have preferred to go on and say, since I want that area, I have already obtained my area. I have already obtained here my area for the whole thing. Can't I just subtract the pi r squared? Which is really very fine. Someone could just get this area, which is the 5, someone could just say 537.4285714 minus the area of a circle, which is the 22 out of 7 times the 6 squared. But now, this one, what you are doing is what we call putting all your eggs in one basket. What if at the start of the question you made an error? It means that everything you are going to do now is going to be wrong. But here, at least you have a backup. You can recover from the initial injuries you had gotten. So that's why, if at all there is an alternative approach, you can also test it and see. But someone, if you are very accurate, this one would have been also this one is very okay. But like I've told you, sometimes when we are starting, we may make a mistake, which can now cost us for every other thing we are going to be doing. So to avoid such, in case there is another alternative, you test it also, such that you do not put all your eggs in one basket. Yeah. So now after getting the area, now we are going to ask, should they paint in jerry cans or tins? Justify your answer. Now we have obtained our area that we want to shade, but they told us that we are going to find out, in case I'm going in for the jerry can, how much money will I need, or how many jerry cans will I need? If I'm going in for the tins, how many tins will I need? Then from there, you're going to find out how much money are you going to spend on jerry cans and how much money are you going to spend on tins. Then from there, you make your conclusion basing on where are you going to save. So now we start with the jerry cans. So I'm going to come here and I just write somewhere here, jerry cans that will be needed. Now, when you look at the jerry can, they told you 300 feet squared. So here I'll come and say our number of jerry cans needed, So here I will say this is our area that we are going to paint. Then I divide by, they told us, by 300. So when you divide, I don't know how much are you getting there. So I'm getting 1.4142857. And I think there, everyone can agree that, because remember, when you read the question, they told that a sealed jerry can, a sealed one. So mean that here, they will not cost 23,000. So here, we shall expect you that you are going to round off and approximate this to 2 jerry cans. So it means that you require roughly 2 jerry cans. And then you are going to ask, how much money do you need? Then you say amount needed for the jerry cans. So you multiply the 2 times the cost of each jerry can, which is 23,000. And roughly here, you'll need 46,000. Now from there, what about the paint? In case you're going in for the tins. So here we say number of tins required. So when you go in for the tins, you're going to ask how many tins will you need. So you show everything, avoid working from the calculator. But they told that for the tin, from our question, for it was painting 200. So here, you'll divide by 200, and then let me keep on dividing as well. So for the tens, we shall get 2.1214285, something like that, 71. So here, when you approximate, roughly, you'll need 3 tens. Now, after knowing that those are the tens, you're going to ask, how much money will I spend on those tens? So I'll come and say amount of money. Amount of money needed for the tins will equal to the 3 tins times the cost, which is the 14,000. And when I multiply, I'll have 3 times the 14,000, which will give us the 42,000. That is the shillings. Now, from here is where now you're going to start coming up with your conclusion. Can someone raise up the hand and you tell us how best do you think you can conclude? Now, remember, if you use 1 jerry can, that means there will be a part that will not be painted. Hope that is okay. If you just use 1 jerry can, it means that there is a part that you're not going to be in position to paint, so you'll have incomplete work. So I would rather buy more jerry cans. I have everything completed, and then I remain with the balance. Yeah. So who wants to conclude for us? Yes. Now, it depends on how are you going to reason. So you reason basing on what you have obtained. Yes, Patricia. Then Proscopia will come next.
Okay. Therefore, I advise is it a man? I advise him to buy the tins in the container. Sorry, to buy the tins, the paint in tins to use for painting his metallic tank, because the cost is much more cheaper than that of the jerry cans, hence enabling him to save some money.
Okay. Okay. Thank you so much. Now, for that one, there is something that has missed. Though I would give you like a small mark. Let me first hear from Proscovia. Yes, Proscovia.
I will first subtract the money, the 4,600, the 46,000 minus 42,000, and I get 4,000. Then I conclude and I say that this man, when he uses the number of tins, he will save 4,000 compared to the jerry can.
Okay. The conclusion, you are almost there. You are almost there, but there is something. Now, yours is okay. Yeah, we have some. So, but I would expect that in your conclusion, you are going to give us the reason why you think you should go in for that particular option you want him to go for. And what are you basing on to say that that option is the best? So you say that maybe I would recommend or I would advise him to use the tins. What is the reason behind that? Maybe they are cheaper than the jerry cans by 4,000. So you give the reason why and what is your view. Yes. Okay. Let me hope we are on the same page. Are we on the same page, everyone? Okay, let me pick Samsung.
Good morning, teacher.
Good
I'm
morning.
lost where we got the 3.
The 3. Did you say
Yes.
we got the 2.124?
Can you please repeat that step?
Like, remember, we had 2 options of using the tin and jerry cans. Now, this is the area we want to paint, but every tin can paint 200 feet. So that's when we divided. So on dividing, we got 2.1214. But on the shops, they cannot sell to you let me say, they cannot sell to you something that is, can I say, half. I don't know that that is okay.
Yes.
So that's why now we estimate to at least 3. I don't know that is okay. Is that fine? Not yet. Okay, let me hope it is okay. Yes, Bast?
Good morning, sir.
Good morning.
What if we leave only 2 and I don't estimate to 3?
Now you ask yourself, will you be able to paint everything?
No,
So will the work be complete?
no.
Hope now you have got the answer.
Yeah.
Okay. Okay. Okay, so read through the second item. Okay. Now, after reading through, we are going to start. Now, when you look at this particular item, it combined 3 things. One, it has an element of circles, of circle properties. And under circle properties, when you look at this line here, this is what we call the tangent. And we know that a tangent is that line that touches the circle at one point. So it has 2 tangents. It has this tangent and it has this tangent. 2, it combined the ideas of equations and finding the distance. 3, it combined trigonometry, the knowledge of elevations and depressions. That means that now you need to be very informed on what to do. Now, they told us that when you look at the problem at hand, they are saying that there is a public outcry on the number of accidents on this junction. However, the government has resolved to put a speed limit on the road users, especially the motorists and humps, every after 300 meters. But the issue has not been solved. An expert from UNRA suggests construction of a road about diameter 12 meters and dividing the highway into 2 roads to Kalanga town as shown. Now, this is what they have come up with. But now they are asking us that determine the length of each load. They're asking, how long will this load here be? That's what they are asking you. Now, in order for us to be able to obtain the length for that particular road, the first thing you need to know is what do you think the distance from there up here? Now, I'm going to first take you back from your knowledge of circle properties. When you are covering circle properties, when I have any circle, if this is the circle, and I have any line tangential to my circle, when I complete like this is where my center is of the circle. Now, any line I draw from the circle to the tangent here, it will form here a radius. And the angle formed at this point is always 90. Whenever a radius meets a tangent, the angle you form is 90. So when I come and I complete this figure like this, like this, like this, it means that I have formed a right angled triangle. Kindly let me know through the chat whether that is very okay. That first step. Is that first step okay? Okay. Now from there, the next thing we are going to do is to ask ourselves, if I have 2 points, I have this point and I have this point, how can I get the distance from Kituntu up to the center of the circle they want me to find? Yes, Marie.
So I'm requesting for your pardon.
Okay, I repeat. I say that whenever you have a circle and there is any line, an external line that meets that circle at one point, that line is what we call a tangent. Now, a tangent, when it meets any radius from within the circle, it forms a 90 degree. So a tangent plus a radius at the meeting point, they form 90 degrees. So that means that when you have a 90 degrees, it means that you are going to form a right angled triangle. So here we are going to form a right angled triangle. So this triangle we are forming here is going to be a right angled triangle. Now, the beauty is that from Chituntu here to the center here, they have given us two coordinates. They have given us this coordinate here. They have given us the coordinate where the center is being formed. Meaning that we are going to use those ones to get the length from Chituntu to the center. And how are we going to get that? We are going to come back here. We are going to come back here. Allow me now to first clear my screen a bit. Let me first clear such that now we can start on working out. So I've said here we should, sorry. So here we are going to come and we have said this is going to be 90. Then I'm going to draw this line here. Now, since from Kituntu to the center, I have a line. This line here has a coordinate -4, -5, and the center here is located at 2, 3. So we need to first find out what is this distance here. Earlier on, I told that in order for us to get the distance, I will say the distance from Chituti to the center. So we say that distance, which I can call d, we said is always given by x2 minus x1 squared plus y2 minus y1 squared. Now here when you are letting, this one can be your x1, y1. This one can be your x2, y2. Even the other way around, it is very okay. So can everyone first fill in the formula as I pick this hand? Yes, not 30 plus not 30 Pro, unmute.
Teacher,
Yes.
I am asking a question here that I see here we are finding the lengths using the formula for equation of line.
That's not the equation of a line. The equation of a line is mx plus c.
Plus what?
Mx plus c. So this is the one for distance.
This is for distance.
Yes.
Thank you, teacher.
Okay. So from here, we are going to come and then feed in our x2 here. We consider it to be 2 minus x1, which was -4 squared, plus y2, which was 3 minus -5 squared. So here we shall end up having square 2 minus -4, which gives us 6 squared, plus 3, which gives us 8 squared. But first put your answers in the chat and I see what you have. Okay. Okay. So when you come here, you notice that this is 36 plus 64, which will give you 100, and we end up with 10. These are going to be the 10 meters. So this is going to be your distance. Now, after getting 10 meters, you know very well that here they have given you the diameter, but we say that this is the radius. So you know that now to get your radius is going to be the 12 divided by 2, which will give us 6. So here we are going to have 60 meters. These are 10 meters. Now from there, I've told that this one forms a right angle triangle. From your knowledge of circles, now if this is a right angle triangle, can't we find the length for this side using your knowledge? You have a right angled triangle. Can't you find the length? Can everyone find out what is the length from here up to here? Yes, Daniela.
Good morning, sir.
Morning.
I was inquiring where this method for distance came from. Is it there like a general method or?
Yes, it is a general method, but it comes from your knowledge. You did vectors, right?
Yes.
Then that's where it originates from. That whenever I have, but I'm not going to explain a lot here. Uh, are you seeing this?
Yes.
Now, if this is your x1, this is your x2, then this is your y1, and this is your y2. How long is from here up to here?
Y1, Y2.
Okay, it is y. Okay, let me do this. In case this is my thing here, and here I have 4, here I have, let me put here 2,
Yes.
then here I have 3, here I have 8, here. Now, you
Yes.
tell me, from here up to here, what distance do we have?
We have 8 minus 3.
8 minus 3. Transfer the same knowledge on this first one here.
Oh, Y2 minus Y1.
What about down here?
X2 minus X1.
X1. Now, what if I want to get this distance here? Which knowledge can you use?
I think you use Sokato.
SOHCAHTOA.
Yeah.
Remember, this is a right angled triangle. Do you remember your Pythagoras theorem?
Yes. S squared
Plus
plus
b
B
squared
squared,
is equal to.
C squared.
Now, your A is x2 minus x1. That is your A, but everything is squared. Your B is the y2, which is y2 minus y1 squared, is equal to this distance you want, which for this case, we call it d squared, d, but you will square it. So when you get the square root on both sides, that's when you come up with that.
Oh.
Mm,
Thank you, sir.
Okay. Okay. Okay, let me hope people have been able. Let me clear my screen. Now to get that distance, I expect you to have used the Pythagoras theorem. So people are getting 8 meters from the chart. Some are getting 11, 8, not 30 pro. Okay, so from there, I expect you to say now the distance or required distance or the length of each load. You say length will equal to now the square root of 10 squared. No, Plo, you are not unmuting. Plo, you have failed to unmute. So it will be 10 squared minus the 6 squared, which will give you the root of 64, and this will give you 8 meters. So I don't know whether people have got 8 or they're getting something different. So I don't know, members, is that okay? You can let me know through the chat. Okay. Yes, Pauline?
Excuse me, teacher.
Mm-hmm.
I thought the hypotenuse is always supposed to be the C.
Okay. Let me pick another hand. It is okay, Pauline? A minute. Yes, Olive?
Excuse me, sir.
Hmm.
We are seeing that right angled triangle. It has a height then and a base plus the hypotenuse. So I'm seeing you are getting 10, then minus 6. I'm not getting.
Okay. Let me first draw this. Are you seeing this?
Yes, I'm seeing it.
Okay. When are you seeing always to be able to know the hypotenuse, hypotenuse cannot meet at 90. Is that fine?
Yes, it's fine.
So whenever you have a 90, it means that that is your base and that is your height for a right angled triangle. Then the other side that remains is always your hypotenuse. Have you picked? I don't know that,
Yes,
Pauline,
sir.
now it is clear. Pauline, is that fine? That your
Yes.
hypotenuse, Pauline, is it fine?
Yes, teacher.
Yes. So where your 90 is formed, that's what forms your base and that's what forms your height. Those two. Then this other side that remains is always your hypotenuse. Hope now everyone has picked. So your answer is 11. Yeah. So people were confusing is that for you looked at how the triangle is, but for any right angle triangle, check out where is the 90. Where the 90 meets, those two sides where it is meeting are the ones that form the base and the height. Then the other side that remains is always your hypotenuse. Okay. Are we good to continue in the chat? Is it now fine to everyone? Okay. Then okay. Then we go to part B. Then here, do not forget to conclude. You'll see now the loads are of length 80 meters. Then we go to the next one. How much money is required for the project to be complete? Now they told you from when you read through that if the road project is to cost 890,000 per meter and in the same trading center. Now they're asking how much money will it cost? So can we calculate the amount that it will cost us to come up with that project? Let everyone calculate now. Not ask.
Teacher,
Yes.
I'm asking. So take you back, eh?
It is well.
Oh, you are first, you are first find the distance from negative 45, and you use these 2 points. When you use this point, you go 10 meters, don't you? And when
Yes.
you go to 10 meters, here the question is saying that determine the length of each load. There are 2 loads. I don't understand it.
Yes. This is like a roundabout. You
There are
have
two
one load that goes this
roads.
side, you have another load that goes
Mm,
this side.
mm.
So the moment you find for one load, it is the same distance because all of them are tangential.
Eh. So teacher, you find it on one load.
Yes, and then you conclude based on that.
Thank you, teacher.
Okay. So can we find the amount of money we are going to spend? Uh-huh. But still I'm seeing the amount is differing. Now, some people are getting 14, others are getting 2-1. Now, do not forget to reason out because these are two loads that we are going to construct. So I expect you to come and say amount of money for the roads, amount is going to be, remember there are two roads. So you multiply the 2 times the distance, which is 8, times the per meter, which is 890,000. So when you multiply 890,000 times 2 times 8, we end up with shillings 14,240,000. Yeah. So that is how you calculate that. Yes, Samsung?
Teacher, I'm confused why the 8. I thought we were supposed to use Pythagoras theorem in order to get the other side of the triangle.
Yes, and that's what we have used.
But when
Remember,
I
you
was
had
using
something like this. Yes?
if
You had something like this. So we have used Pythagoras theorem. But here, the only thing you needed to know is that your thing was like this, whereby this was your 90, this was 6, and this was 10. So this side here is the length we are looking for. So when you use Pythagoras theorem, it becomes 6 squared plus L squared is equal to 10 squared. So when you take that 6 squared, it becomes 10 squared minus 6 squared, which gives you L squared is equal to 10 squared is 100 minus 36, which gives you L squared is equal to 64. Then you get the root.
thank you, teacher.
Okay. Uh, Marita,
Morning, sir.
morning.
Shami, I'm like asking
Hmm.
why yet the whole project needs like why only 8?
8.
Because
We have multiplied 8 times 2 here.
yeah,
Hmm.
yes.
Remember, the aim of the project is to construct this load here and to construct this load. And you have noticed that this is 8 meters, this is 8 meters. So
Oh,
the total distance to be worked on is 16, then times the cost per meter, which is 890.
get sharp. Understood.
Okay. So we are going to continue now and then look at the second part. Now the second part, oh, the second part required us to use, so I want to first clear now the screen. Now the second part asked us that it was observed that the angle of elevation to the top of the building from a point on the road A is 38. When a distance of 30 meters is moved towards the building, the angle of elevation is 72. Help the construction team to calculate the height of the building. Now, you need to know here from your knowledge of elevation, we have basically two angles. If this is a person and you look up like this on something up, this angle here is what we call the angle of elevation. Elevation, like you look up, like when you are seated, when you look at the top or at the ceiling of the house, or when you look at the iron sheets, you are using an angle of elevation. However, when you look down, let me say you are looking down here at the floor, then the angle you are viewing is what called the angle of depression. So depression always brings you down. That's why whenever someone is depressed, is always down, is not in mode, is somewhere there. So an angle of depression, it brings you down. Angle of elevation, it lifts you up, it gives you energy to wake up and do things. So elevation, you look up. Depression, you look down. Now they are telling us that there is a building that these people are looking at. Let me say this is our building that people are looking at. Let me say. Now they have told us that what happens that it was observed that the angle of elevation to the top of a building from a point on road A is 38. In other words, when someone looks at the building, let me say someone is here and looks at the building, the angle he has used at this point here, he has found out it was 38 degrees. That is the first interpretation. Now they told you that, oh wait, A is that when a distance of 30 meters is moved towards the building, so when you move towards the building now, the angle of elevation is now 72. Now, you are going to move. So this was the first one that the person. Now, if this person, let me say this is where person A is. Now, when he moves towards the building, the angle here changes. Now, remember they are still looking at the top of the same building. I'll look like this. So you notice that the angle here has changed and now they're telling you it is 72 degrees. But which distance had this person moved from here up to here? The distance the person had moved was 30 meters. Kindly first let me know whether that is very okay to everyone. Whether that first one is fine. Okay, I'm going to repeat. Though in the chat, I'm seeing two things that I want to make clarification on. One, please, I repeat, do not cram. Do not cram. The moment you cram, you are going to miss fire. Whenever you have a right angled triangle, where 90 is, one of that side is always the height, another one is always the base. Or if you want to put it the other way, one is the adjacent in that terms. Then the other side that is formed is always the hypotenuse. So do not cram that because you have seen the figure is like this, and like this. And you think that because this one is slanting is always the hypotenuse. No, 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 no. The hypotenuse is always determined by where the 90 degrees are. If this is where the 90 degrees are, this one is going to be your hypotenuse. If I form a triangle, let me say like this, and this is where the 90 degrees are, then this side is going to form the hypotenuse. Hypotenuse is based on where the 90 is. The side that where the 90 faces is the hypotenuse. So that's what you need always to look at before you make any conclusion. So for you look at, no matter how the figure is, for you look at where 90 is. If 90 is here, this side here now becomes the hypotenuse. Then the other two sides, one will become your base, another will become your opposite. Okay, now that one is done. So I come back here. They have told you that there is a building people are looking at. Let me say this is the building. So when one person views the building, this is the first person. He looks at the top of the building. The angle he's viewing at that building is 38 degrees. Now remember, the more you move closer to the building, the bigger the building appears. Now when the person moved close to the building, here you notice that the angle has now increased from 38 to 72. But he had moved a distance of 30 meters. That's the meaning. Because the more you move closer to the building, the bigger the building becomes. When you move far, the angle keeps on reducing. I don't know that that is clear now.
Teacher,
Yes, please.
I'm asking,
Yes.
how can an angle,
Yes.
how can an angle,
Continue, continue.
how can an angle be increasing when you are coming to it? When you are so far away, decreases.
Okay. Like when you are traveling, or when you are traveling,
Mm,
or when you look at a
mm,
person when the person is very far from you, does that person
mm,
appear small or big?
mm.
When a person
Appear
is very
small.
far from you, appear small. When you get close to the person, does the
Mm,
person appear big or small?
appears big.
So appearing big, it means that the angle is bigger. The angle of elevation is bigger.
Mm,
For you to view that person as small, it's because the
mm,
angle at which you are viewing the person is small. So the more you move closer to the person,
eh,
the more clearer, the
mm,
bigger the person becomes.
eh.
Yeah. So
Thank
for you
you,
look at
teacher.
those objects that are very far. When you are very far from them, they will appear small. The
Mm,
moment you get close to them, they appear big.
mm,
Okay.
big.
Okay, now
Okay, sir.
from here,
Mm,
I'm going to use this second sketch as my sketch, this one here. Now, this one is going to be our height for the house. That's going to be our height for the house. Now, if that is the height for the house, I don't know. I have two things I can do. Since I don't know the distance from here up to here, I can call this one to be my x. I don't know the members agree with me. Now, if I call that
yes.
one, yes,
Teacher,
yes,
why you put there X? Why have you put there X?
because we don't know the distance from there.
Mm.
So that's why we are calling it
So
x.
you have put it X.
X is unknown. We don't
Okay, sir.
know. Okay. So
X.
if we put here x,
Mm.
now we are going to go on and use our knowledge of right angles. So when you look at this figure, you'll notice we have two right angles. The first right angle we have is this right angle here. This is one. Then the second right angle we shall have is this one here that I'm going to draw in blue. This right angle here. This is the second one I have. Now, when I extract the first one, let me say I have extracted this one here. If I extract the angle here I have is 38 degrees. If I call this one to be my h, members tell me through the chat, what distance do we have there? What distance? You can place your answers in the chat. Mhm. Through the chat, people are putting the answers 30 plus x, 30 plus x, 30 plus x. Very good. So here, I'm going to come and say this distance here is 30 plus x. Very good. Now, remember here, for these right angles, we use the knowledge of trigonometry. Remember from your trigonometry, if this is h, this is 30 plus x, and this one is 38. This side where your angle faces is the opposite. Where your angle sits is adjacent. So when you go back to SOHCAHTOA, which one are you going to use? Which has adjacent and has opposite? Which one are we going to use? Tan. Very good. So it is the tan that has both. So here I'm going to come and say the tan of 38 will equal to my opposite, which is h. This is the opposite here, divided by the adjacent. So we shall have our opposite out of the adjacent. So I will say tan of 38 will equal to opposite, which is h, divided by adjacent, which is 30 plus x. Now from here, since I'm interested in finding the height, I'm going to make it the subject of the formula. So to make it the subject of the formula, I can just cross multiply like this. So when I cross multiply, you will notice that here I'll end up obtaining, this is going to be h equals to tan of 38 into 30 plus x. So this one is going to be my first equation. Then from there, I'm going to extract the second one. The second one I told you, it is this one here. So also I draw that right angled triangle like that, like that. So here we have x, here we have 72, and here we have our h. So still I do the same, that tan of 72 will equal to opposite out of the adjacent. So I'll have the tan of 72 equals to opposite, which is h, divided by the adjacent, which is x. So still, when you cross multiply, you'll have your h equals to x tan of 72. Kindly let me know through the chat whether we are on the same page. Are we on the same page? Okay, yeah, same page. Now, what do we want? Now, when you look at the question, they wanted us to find the height of the building. Now, in order for you to get the height of the building, it means that one of the things you don't like is the x. You don't want x. So that means that you can eliminate x using one of the equations. So in order for me to eliminate x, I'm going to come here. Allow me to come and I first clear here. To eliminate x, you are going to allow me to use one of the equations to eliminate that x. Now, which equation am I going to use? I'm going to use this one because here we had that h is equal to x tan of 72. And in case I want x, I'll divide by tan of 72 divided by tan of 72. So here I'll have my x equaling to h out of the tan of 72. Now, this one that I've formed, I'm going to come here on the first one. Wherever there is x, I put h out of tan of 72. Kindly let me know through the chat whether we are still on the same page. I've said, I repeat, you come here where your h is equal to x tan 72. That is the first thing you need to know, that h was equal to x tan of 72. But what do you want? You want x here such that you can be able to substitute it here. So that means I'll divide this side by tan of 72. I divide this side by tan of 72. So this and this will cancel. So you remain with h out of tan of 72 is equal to x. Now, after obtaining that, I'm going to come. The equation we had at first was x is equal to tan 38 into 30 plus x. What are you going to do? Where there is x here, you are going to put h out of tan 72. So I'll say h will equal to tan of 38 into 30 plus x, which is now h out of tan of 72. We are now substituting. So when we reach here, we are going to open up the brackets because this tan 38 affects everything. So now I'll come and say h is equal to 30 tan 38 plus h tan 38 out of tan of 72. Now, when you reach here, feel free to place your calculator. 30 times tan of 38. But we said that for trigonometric ratios, always write to 4 decimal places at least. But since we are still calculating, I advise you to write to 5 and above. So tan 38 when you place your calc is 0.7812. I've said I'll put 9. Then when you check out tan of 72 on your calculator, tan of 72 will give us the 3.07768. So those are the ones I'm going to substitute. So here I'll say 30 times tan 38, which is 78129, plus h times tan 38, which is 0.78129, divide by the 3.07768. So you compute, you do your mathematics, h will equal to the 30 times 0.78129, which will give you 23.4387 plus, now divide the 2 here. So you'll have 0.78129 divided by the 3.07768. Yeah, which will give us here 0.25386 h. Then you collect like terms, take the h the other side, then you have h minus 0.25386 h equaling to 23.4387. So when you continue to subtract 1 minus 0.25386, you end up with 0.74614h equaling to 23.4387. So you divide by 0.74614, divide by 0.74614. So when I divide 4387, yes, 4387 divided by this, I'll end up with my height h as 31.41327. So kindly first check out whether you are also coming up with the same thing like mine. Okay, let me pick up a hand. Yes, Mugisa?
Teacher,
Yes.
for sure, this method have totally confused me, but I have another option. I don't know if it is true. For
What's the
example,
second?
here we have
Yes.
obtained the value of first h and then the second h. So I'm asking that if I say that x equals to x, I mean h equals to h, then I get the first answer for the first h equals to the answer of the second h. Then I deal with that. I first obtain the value of x. Then after
That
I
is very
use...
okay. That is the second option, eh?
Okay.
You could first equate the two, then you say x tan of 72 is equal to tan of 38 into 30 plus x. So you work out and find the value of x. Now, after getting the value of x, You go on and obtain the value of h by substituting in any. It is very okay.
Okay. Thank you, sir.
Yeah. So for you here, just fill in tan 70 to put the answer, put here, and then work out the value of x. Let me just work it quickly here, and I tell you what you are supposed to get. Minus tan 38, and then 30 times the tan 38 divided by so here you'll get your x as 10.2067 and then you substitute. Okay. Yes, Gavanian.
Master,
Yes.
I was asking where did we get the 0.7?
Yes. Remember here there is an hidden one. So 1 minus 0.2538, you get 0.7. So that. Yeah.
Okay.
Okay. So allow me now. I'm going to first clean my board and then I use that second option such that people can see how the other alternative they could have done. Why I didn't want to go in for that one, it is because X was not required. So, but let me use it such that people now can see how they can use that approach. Now, the second alternative would have been for you to come after getting your H. So 1H, we had it as tan 38 into 30 plus x, and then the other h was x tan of 72. So since the h are the same, you can just equate. So here I would have said tan of 38 into 30 plus x is equal to x tan of 72. Now, here I can note that tan of 38, we obtained it from here, that tan of 38 is equal to this. So here I would say 0.78129 into 30 plus x will equal to x times tan 72, which is 3.07768. Now, when I reach here, I open the brackets. So I'll say 0.78129 times the 30 plus the 0.78129 times x will equal to 3.07768 x. Then I'll come here. I multiply that times the 30. So here I'll end up with the 23.4387 plus the 0.78129x equals to 3.07768x. So you collect like terms. You take this one with x this side. So that means here I would have gotten 23.4387 equals to 3.07768x minus 0.78129x. So we are going to subtract those two. 3.07768 minus 0.78129, and it will give us here 2.29639x equaling to 23.4387. So when you reach here, since you want x, you divide by 2.29639 divide by the 2.29639. So when I divide from the calc I have here, I'll end up with 10.2068 equaling to x. Hope now that one is a bit okay. Then from there, Now I can go and use any of the equations to find h. So allow me to pick, this is the one here. I want to pick this one here. So it says h is equal to x tan of 72. So here I'll know that my x is 10.2068 times tan of 72, which is 3.7768. And when you multiply those two, you will be able to get your 31.413. Yeah. So that is what you are getting. Okay, so let me hope now it is clear. Let me pick on one hand, not 30.
Teacher,
Yes.
I can use the first equation here in the first option you have given to us, to find the value of x.
Yes.
It is possible.
Yeah, it is possible, but now there you are going to combine. In simple terms here, we are solving a simultaneous equation. So you combine the two equations such that one unknown is eliminated from your equation.
Okay, teacher.
Okay. Marie?
So I have another option, but my answer is somehow different because
What was your option?
I first found the other side of the triangle with the 72 degrees using the sine rule. Then I got the side of the height using the Sokato. Then
How did you get the other side?
I used the sine rule.
The sine rule. You state for me the sine rule.
It is A out of sine of A.
A out of?
Sine of A is equal to B out of sine of B is equal to C out of sine of B.
Okay, which triangle did you look at?
I first used the other big one.
The big one.
This one at 8 degrees.
Then
I found the other side, the slanting side.
You found this slanting side. Okay. Let me first clear my screen.
This side with 70 degrees. That the slanting side.
Here.
Yes. Then after getting that side, then I got the height this side.
Okay, what was the height here? The slanting
side. It was 33 point.
How did you get it?
I used the sine rule.
Okay.
Mama, quit.
Okay, what was your A? What was your A?
My A was the side.
Okay, which side?
That slanting side.
Here.
That yes.
Then
the angle.
Then your angle?
38.
Angle was?
Sine of 38.
Continue.
Then it was 30 because it was 30
Your
because
B?
this 30. Yes, 30
Your B was
meters.
30.
Yes.
Then the angle?
The angle was 34.
34. A minute.
Yes. Because I got the interior angle sum.
Okay, this is 34, correct? Okay. So your A
Then I
here.
cross multiply.
Okay. Let me quickly do it here. So here, this is 33.02946.
Yes. Then I went this side to the second triangle. I used the soccer 2, then I found out that I was supposed to use the sine is equal to opposite out of hypotenuse. Yes. Then I got sine theta, yes, is equal to yes. It's opposite out of hypotenuse.
Okay. Yes. Which is okay.
Okay. Then I cross multiplied again. Then I got the answer as yes, that one.
Yeah, it is very okay. It is a very good approach as well. Yeah. Okay, thank you. Yes, so those who want, you can use this second approach. Yeah, but if you don't know how to use the sine rule, then yeah. But what she did, when you look at this triangle here, when you look at this triangle, this is one triangle. So the angle here is 38. You can find the angle here. So to get that angle, you say 180 minus 72 because those are angles along a straight line. So here, you'll end up with 108. Now, after getting 108, you get this angle here. So you know that that is 180 minus 18 plus 38. Then you get that angle 18 plus 38, 180 minus the angle. So here she ended up with 34. And you know in our sine rule, when we say A out of sine of A equals to B out of sine of B. So here our side here is what she named A. So you say A out of sine of 38 equals to the B. So B, we have this side down. So the angle there will be 30 out of sine of 34. So you can use that approach. After getting this, you use, okay, a minute. Yeah, so after you can use that approach. Yeah, but you can practice and then use that method. Okay. So let me hope we are on the same page and do not forget always to respond back to the question. So here I would conclude that the height of the building is 31.4 meters. And here now we do not expect you now to round off because now this one is accuracy. So you just say 31.4 something and then you end at that point. Okay. Okay. Yes. Okay. Then I had another item here that I want us to look at. Now, when you are learning, we have what you call the nets. A net is something you obtain when you open that figure fully. When you open a cube fully, this is the kind of figure you get. When you open a cuboid, this is the kind of figure you get. But like when you open those boxes, in case you have a box at home and you open it fully, what you obtain is what we call a net when it is flat. Then when you put it back, then it becomes a real figure, a 3D figure. Now, for each of the figures we have, you must know how does the net look like? Because when I was going through one of the mock papers, I noticed that they gave them a net and they wanted them to draw an archlet diagram of the final figure, how it looks like in a 3D format. So now that's why I had to bring to your attention the different nets that are common for the different figures that we are doing, such that you know that in case the figure is like this, it means that this is the kind of figure that I'm likely to get. Now, these are some of the common 3D figures that we do have. Okay, so look through them and then we are going to continue. Okay. Okay. Now since we have been able to see them, I can now proceed. Now, I want you to look at this figure because the figure I saw in one of the mock papers, it looked like this. I know some of you have attended church services where they put stages of this nature. Now, I'm going to trace out this stage such that I want you to, at the back of your mind, this is the kind of figure, depending on the scenario that we are going to work with. So the scenario, they gave us a figure and they gave us the way you see this kind of figure. That this is what I was able to figure out personally. I don't know what for you are going to figure out. That this is the stage, the way you see it here, like this. On this stage, there are, hope you are seeing, like this. Then this side, it has the way it goes this side like that, and also this side, the way it goes like something like that. Then down here, you know that at the floor here, this is where they put the timber, the wood. I don't know now. Everyone first tell me whether you have figured it out. Hope we have figured it out. Now I want you to come. Sometimes when you go to those concerts, you will notice that the stages, it can either be of this nature here, or sometimes it can be of this nature, depending on depending on the level of the person. Now, after figuring out, I want us to relate to this kind of scenario we have at hand. I don't know whether you are able to relate the stage I have showed you and what we have here. Are you able to relate? Tell me yes or no. Eh, no, answers not yet. Kinda. People are still relating. I don't know that now I need to, let me first bring the other picture closer to this such that people can be able to view it very well. I wanted to, should I bring this? Let me first bring this picture a bit close to this actual one such that people can, at least I want you to, you have to first figure it out very well before we continue. Now we are going to figure it out together. Now when you look here, you are seeing this, and this. Now I'm going to draw on the other figure using the same thing. So this side, you are looking at this, you are looking at this, you are looking at that. Kindly let me know whether that first part is okay now. We are figuring it. Is that okay? Now from there, I'm going to use another color to figure out the second part. The second part I'm going to figure out are these stands here, this one and this one. I come back on my stage here. This pole here and this pole here. Is that one also okay? That one is also okay. Then now we figured out the other part. Now the other part that is very confusing is the wings. Now these wings, I think it was the pictorial, how they were drawing them. That's where the problem came. But when I look at this side here, I want you to look. I know you cannot be able to see this side, but that side of that nature. That's how that wing looks like. Then this wing, I think also it was because of the art, but also I think this was another wing. The other second wing of this side here, I don't know whether we have tried to figure it out a bit. I don't know whether now people have figured it out. Have we been able to figure the figure? I think it became because of the art, drawing it on the computer. I think that's where the problem came from. But I don't know whether people have figured it out now. Kindly let me know through the chat whether it is okay now. As I pick on, I pick on Raban. Yes, Raban.
Teacher,
Yes.
I see here we have compared this figure to the other figure of the stage.
Yes.
But teacher, here I see the stage is like they have the 4 stands. But on this figure, I see only one or 2 stands. How comes that you have compared these two things, teacher? I don't understand there.
Now, remember, we are dealing with a 2-dimensional figure here, and the stage you are seeing is a 3-dimensional figure. So I'm trying to compare to you what we have in real life with what the illustration they came up with. Now, since it is a 2-dimensional figure, a 2-dimensional figure can't show everything. It only shows you some parts, yes. So you
Okay,
can't
sir.
see everything, yeah. Okay. Now, looking at those two things, depending on the person who was setting, this is what the person was figuring out. And that's what the person wanted us to come up with. He wanted us to come up with a figure of this nature. A figure, because now the scenario wanted us to come up with a figure. And remember, this is the stage down here where they usually put those wood thing, what, down there. So this is how you had to figure it out. So that's why sometimes attaining some of these functions is very important, at least going to church, such that you have those mathematical figures in nature, such that you can easily relate to what happens in real life to the scenario that has been given. Next time, they can give you something like this. So in cases like this, also you need now to relate that sometimes it is triangular in form, sometimes it's a bit, it is a semi-circle. Yeah. Now from here, the scenario went on and told us what they wanted. Now from the scenario, they wanted us, one, to draw an accurate 3-dimensional figure illustration of the state stating all the length involved. So now what do I expect you? I do expect you to you'll come up with an illustration like this one here as your 3-dimensional figure. But whenever we are drawing, we draw them on a graph paper, The beauty is that, one, when you are drawing this, here, you know the distance here, which is 10 meters. Then from here up to here, they have told you that this was 12 meters. Meaning that also here, you're going to have your 12 meters. The other side, you'll also have the 12 meters. These stands here, they have told that these ones were 1.5 meters. Then, what you need to find out, what about from here up to here? What distance was it? So you know very well that from here up to here is going to be your 6. So you use your Pythagoras theorem to find out what you have within that part. Yeah. Let me hope people have figured it out. So that is what we are going to do when it comes to that 3-dimensional figure that we are going to find. Then when they ask how much space is occupied, we are looking at mainly the volume. That is what we call the space being occupied. Then when they ask how many pieces of wood will be required, it means that now you look at the floor that you have and then check out which area is being covered by the floor. And then from there, you use the dimensions of the wood panels that they have used in order for you to find out how many you will need. So that's what you had to do for that part. I don't know whether yes, Marita. Yes, that kind of figure. Yes, I don't know whether we have picked something. Has everyone picked something on what we have to do on that particular part? Okay. So this was in Wumuta. Then another one that I wanted to bring to your attention, another scenario was about this. Now this was a pyramid. It was given as the project to the children. So, but what was important is you knowing how do you calculate the volume. Then also they asked the angle between the slanting side and the base of the wood. Meaning that here, you need to remember your SOHCAHTOA. So I'm starting to give you the homework. The first number I wanted you to try out now is this one. So you can take a screenshot of that. Okay, from there, I'm going to give you that one as well. You will try out this. Okay, I hope people have finished. From there, we are going to try out this as well. Okay, I don't know that I have another one. I have another one. After this, there is another one here. You can also try out. All those numbers are lying within the same caliber. But now this one, I think. Dun, 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 dun. Also, this one lies. But do not forget, I told you things of the ratios, proportions, they can appear in any part. Yeah, so those are the numbers I want you to try out in your when you get time. Yes. So, okay, let me pick this hand. In case you have a question, you may ask. Yes, Rabban.
Teacher, I want to thank you for this session. That is why I have raised my hand.
Okay, thank you, Rabban. Okay, yeah, so okay, Samsung, do you have a question? Okay, so you are going to try out those ones, and then tomorrow, I was thinking that tomorrow, I don't know which part you want us to look like, but I wanted us to look at item 1, and then we focus on where they have brought in some SADs. So you may let me know through the chat what you want us to look at. And
Excuse
then,
me, sir.
yes.
Yes, so I was requesting that if we look at that part, then also we look some things more about the bases, because I have found very many numbers where they are setting the bases in form of pins.
Okay. 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 We shall look at it, I think, tomorrow as well. Okay. Yes, Milton.
Morning, sir.
Morning.
Thank you for this session. What I wanted is you first provide me those slides again and I make screenshots.
Okay. Let me run them
I was off
again.
for a while.
Okay. Okay. So, yes, Chidabo.
Teacher, good morning.
Next
Thank you for the
Morning.
lesson. I just wanted to ask if you could do also more circle properties, because I really do have a problem with that tomorrow. As well as sets. Yeah.
Okay. We shall see what we can do. But those who have some numbers on SADs that you may want us to look through, you may send them in my inbox. Yeah, you can send them, but I'm also going to look out for the ones we can do tomorrow. Okay, so allow me that we end here for now. I know for the recording, I may take some time, but also it will come. It will come, so you can keep on reviewing those recordings where you are finding some challenges. Then from there, that's where we shall keep on learning. Then lastly, Marie,
Just wanted to give a closing prayer.
Okay, Marie, you can pray for us.
Let's humble ourselves for the prayer. Almighty Father, I want to thank you for this day. We thank you for all that you have given to us. We thank you for the knowledge that we have received from our teacher. Pray that you may bless him, bless all our supporters in this kind of education. Thank you for all that you have given to us. We pray for our dear parents that you may enable them, get the school fees and everything needed for us to go back to school so that we can have a successful term. We also pray that you may give us gift life and take us through this journey of education successfully. Amen.
Amen. Thank you so much and have a lovely